All right, so let's talk about how separation of variables works with our differential equations, kind of more real lifey here. But here we go. Remember how exponential growth and decay works, where you've got y equals some initial value a times b to an x power, where a is the initial amount, b is the exponential constant. So it grows if that x is greater than 1, or if b is greater than 1, it grows. If b is less than 1, it decays. And the related differential equation for this is dy dt, okay, the change in y over the change in time equals k times y, okay? And this is where k is growth or decay. So let's solve out this differential equation. And this is going to require a little bit of a leap of faith from some of you guys. Kind of follow along here, and if you don't understand everything that's going on right away, that's all right. It will start to make sense as we work through some of these problems. So here I've got dy. This is really bad handwriting. I don't know what's gotten into me here. Maybe I'm hungry. Let's try this again. Okay, so dy dt is equal to k times y. Remember, k is just going to be some sort of constant, okay? Well, what we need to do is we need to separate these variables. Notice I have y over here and y over here. I've got to get y's together, which means dt needs to go to the other side. So I'm going to take a 2 for the price of 1 step here. I'm going to divide both sides by y, multiply both sides by dt. Now watch here. This is really cool. dy over y equals k times dt. Did you see that? Did you see that? Okay. This is straight out of Algebra 1 101, all right? So dy is actually going to be, maybe an easier way to think about this is 1 over y dy equals k dt. Okay, now integrate both sides. All right, and this is going to be a little bit on the weird side here, but just work with me because we're headed someplace grand. Remember, the derivative, the antiderivative of 1 over y is natural log y. And remember that the natural log only works if the with absolute value of y. Okay, it's got to be positive. That distance has to be positive. And that's going to be equal to k times t, okay, plus another constant, okay? So two things now. This constant can be anything right here. And even though we integrated this side, this constant takes care of the possible constant on the left. Okay? I know it's weird. Just hang in there. It will all be okay. Now, I've got to undo this natural log because remember, we're solving for y. And the way that you can undo a natural log is by using the exponential function. So basically what I'm going to say is I'm going to go e and e. All right, just like this, e to this power, e to this power. This is an equality statement. I'm doing it on both sides. There's been no cheating going on. And what that's going to give me then on the left is absolute value of y equals e to the kt plus c. All right. Again, I know this is different and perhaps a little strange to think about how to solve a problem like this, but it's totally on the up and up. Now, keep in mind how the powers with exponentials work. Notice down here I've got e to the kt plus c. So what I've got is e to the kt times e to the c. Okay, and remember, I can do this because if the bases are the same, then I add the exponents. Look what I'm doing down here. I'm adding exponents. The bases are the same, so I can multiply those bases together. Now, let's address this whole absolute value thing. Remember, absolute value says we've got to be either positive or negative. It doesn't matter too much. And so the next step on that would be to change this c part to account for the positive or negative. So this is going to look really weird, but hang in there. Y equals plus or minus e to the c times e to the kt. All right? Again, I didn't do anything crazy. Remember, if we take the absolute value of this guy, we're going to have positive e to the c or negative e to the c. And if we take absolute value, we'll always get that positive version out. Well, this should start looking familiar to this guy right here. Notice, this is a constant. This is a number. This will be our initial value. So we will actually end this guy. We will let A represent plus or minus e to the c. So our solution for this differential equation will be y equals a times e to the kt. Now, that we've seen before. E is our base, k times t is our exponent, and I just think this is a really neat thing to do and understand, because the next few problems that we work out are going to be based off the formula that we just discovered.